Okay, so I'm recording this session. Hopefully I'll post it by tomorrow. It takes a while for YouTube to process it. Okay, so I want to talk about generics, and I want to talk about, what else do I want to talk about? I want to talk about the assignment a little bit. So, and then we'll eventually use generics. This will not be on your next quiz. Okay, so the next quiz, because of the break, it's going to have to be about, let's see if I can do this. Okay, okay, so let's see, I thought, somehow I'm sure, okay, so anyway, I'm gonna record, I'm just gonna continue. I was trying to do, I'm still not an expert at Zoom. Um, so, um, uh, uh, okay, so let's see, what was I talking about here? So the next quiz will probably be about just inheritance, some review, and then I'm gonna, over the weekend, I'll post, am I muted? I can't.
No, I can't hear you.
Okay. Yeah, it looked like it was muted on my screen. Um, so, um, so, uh, so, uh, and so, yeah, and so then plus be some other review courses that I'll let you know about. And so let me just share the screen. I'm going to go to Eclipse. So where is Eclipse? Eclipse, right here. And let's see here. So you should see Eclipse, and so this is not what we want to look at. So let's go right here. Okay, here. So, okay, here. So I posted, I just actually put up a folder called um, I think it's lecture 4 generics. And this is, oh, there's a typing error in here. And the whole point of this is just to see the difference between arrays and array lists. So I'm not sure if you're familiar with the, so if you're not familiar with the array list, I have some notes I'll put, I thought I might have forgotten to put the notes up yet. I'll put it up after the lecture. I know I put it for the other class. But what you see there on line 12 is a perfect example of array list. So it's just an object. So it's kind of like an expandable array. So we know that arrays are fixed length. We can't, if you say that like that line 23, the array is of length 4, well, we can't make it any bigger than 4. We can't make it any less than 4. It's exactly 4 elements. Okay, but an array list, you declare the array. So we say the name of the name of the class is array list, and see what we see, that string. It's in like the greater than or less than sign. That's called the diamond operator. That's a generic. So that string inside the diamond operator is an example of generic. The name of the variable is ARR list. And then on the right side, we just call the array list constructor new array list. The parentheses is for the constructor is no parameters. And because we're using generics, we use the diamond operator on the right side. And there was a time in Java world, like in Java 1, before Java 1.8, we would have to put string on both sides. So what this means is that this array list, this collection can only store strings. But it's expandable. It's not a fixed length. And to add a string, all you have to do is use the add method. The name of the array list variable dot add is the name of the method, and then we add any legitimate string. So I'm going to take this string out. Whoop, not that. I'm going to take this string out here because that is starting with Java 1.8. They just said, well, if it's string on the left, it's implicit that it's string on the right. Okay, the one thing about this array list, because we put string, is that we are restricted to strings. So if you see there on line 15, I try to add what's called an integer object. There is an object built into Java with an uppercase I, but we don't actually have to say new integer 6. We can just, it converts that 6 to an object. It converts it to an integer object. But you can see there, we get a red dot because the array list is declared as string, but now we're trying to add an integer, and the compiler will flag that. So I'm going to talk about that a little bit, why that is. And that's one of the big things. That's one of the big advantages of generics. Okay, so we have a collection of strings, and if we add something other than a string, the compiler will flag it. Okay, so now let's go to I'm going to keep one of these commented, one of these uncommented. So now here's the second section. Now I'm going back to what we learned in Math 130. We learned about arrays, so we see that X on line 23 is a collection of object values, an object with the uppercase O. So object, so we use this word object two different ways. When it's an uppercase O, we're talking about the highest level class in Java. And so that we're saying X is a collection of object values. But this is a legitimate assignment statement. And what are we assigning to X? An array of strings. Because object is the parent of string. Every string is an object. So we can assign an array of strings to an array of objects. But here's the thing. This is the important thing. For the array list, the compiler knew that ARR was a collection of strings. But the compiler doesn't know about polymorphism. So what the compiler does, it looks to the left, and that's all it knows about X. All it knows is that X is an array of type object. It doesn't know that at runtime it's really going to store strings. Okay, so it makes sure that there's a legitimate assignment statement, and it makes sure, and that's all it does. But as it proceeds, X is all X, like in line 24, all the compiler knows is that X is an array of type object. And remember, the compiler is, we type our code, and the compiler parses it's like a word processor. It's checking that everything is spelled correctly. And it's also making sure we're not calling methods that don't, like if we declare, say X is a string object or A is a string object, and then we call a method that's not in the string class. So it's making sure that we're not calling methods that aren't defined in the class. It's making sure the assignment operations are appropriate, like we're not assigning double to int, stuff like that. But okay, so the compiler is looking at our code. It goes, oh, X sub 0 is assigned to cat. That's okay, because X is an array of objects with the uppercase O, which means we can assign any kind of object we want to X. And then X sub 1 is book. Okay, that's fine, because they're objects. String, and then in line 26, we have now assigned an integer object to X. And now we're not getting the red dot, not like we do in line 15. I should have commented this out. Because all the compiler knows is that X is an array of type object. And so here's it's kind of a subtle thing, but now we're going to run this. And we better get a runtime error. And we do, if I can scroll down here, at line 26. The program crashes at that point because at runtime, the runtime environment knows, because remember the compiler parses, converts the .java file to a .class file, and then the Java runtime environment opens up the .class file and starts executing the bytecode that's in the .class file. But at runtime, the runtime environment knows that X is really an array of strings. So it says, okay, well, so 24, no problem, 25, no problem. But then the runtime, we're actually running the code's executing, and it tries to assign 6 to element 2, and it can't, because at runtime, it's really an array of strings. So at compile time, X is an array of type object. At runtime, it's an array of type string. And it's kind of subtle. That's the polymorphism. That an object variable or an array variable can change its true nature during runtime. Now that's the whole point of polymorphism. And so I can assign a new value to X if I want. I can say X is now an array of type integer. See, X can change its data type during runtime. So that's why the compiler doesn't make any assumptions about the data that's assigned to X. All it does is it looks at how it's declared. Okay. Whereas in array list, the compiler will actually check the data type. So that's the advantage. So if we use array list with generics, the compiler checks to make sure we're adding the correct data type. And let's uncomment this. Oops, that was not good. I'm almost done with this example right here. See, the compiler knows that 6 cannot be added to an array of strings, but the compiler doesn't have a problem with line 26. It's the runtime environment that does. So that's really one of the advantages of generics. And we'll be using array lists and linked lists in our class. And we will be using generics. In fact, we'll have some kind of assignment with generics pretty soon, maybe next programming assignment. So unless there's questions on this, I'm going to stop sharing this, and then I'll open up the PowerPoint slide, which should be online, I hope. I did, yeah, just go to that lecture 4 folder, and let me know if you can't find it. I'm going to stop sharing this. So unless there's any questions, I will continue to proceed. Okay, so I'm going to share the screen. So these are maybe these are actually the PowerPoint. I think they're the same as the PDF I uploaded. Okay, so this is actually an interesting material, and certainly useful if you know, if you ever do any more Java programming. And so generics, I think, got introduced in Java 1.5. I don't know the year. And the one thing about Java originally, it was kind of a simple language. Like from Java 1.0 to Java 1.4. That's what made it so popular, I think, when it came out, is that there are no, unlike C, there are no pointers. Indices, the runtime environment checked to see if our array indices were out of bounds. Like with C, your indices can go way out of bounds, and your program is now kind of going into parts of memory that it really shouldn't, and you get terrible results in your program. Your program is kind of worthless. So the programmer really has to make sure that there are no, what's called a memory leak, going to parts of memory that aren't really available to our program. So Java was this simple language. It was really wildly popular. I mean, it still is, but with generics, I think it became kind of a complicated language. I mean, to really understand, I don't know all the rules for generics. It's just a million rules. I know some of the basic rules. And the one important thing is that all the code in Java 1.0 through 1.4, we can't break it. When we add a new feature to the language, we don't want to break the old code. Whereas in some languages, they do that. Like Python 3.0 broke all the Python 2.0 codes. And then they eventually, I think, added something Python 2.7 to kind of act as a bridge between Python 2 and Python 3. But yeah, but Java so far hasn't done that. You know, maybe when there's so much code, maybe when all the old code gets replaced, but we're still running really old code. I mean, decades old from other languages. Okay, so here is, okay, so this is what the ArrayList class. So there was this ArrayList class. So remember when you download the Java Development Kit, you get all these classes that are all these useful classes to help us write good programs. And one of the classes was ArrayList. And this is what it would look like before the introduction of generics. There was an add method, and we could add any kind of object we want in the world to ArrayList. And then there was a get method, because the thing about the array list, these objects that we're adding are ordered. So we can say there's object 0 and object 1 and object 2. So you put in an index and you return the object at that index. So you're always returning an object of the highest level class. Because the idea is we can add any kind of object. So, you know, we have to assume that the object being returned is the highest level. And then I say other code. So part of the other code is, there's actually an array that's actually storing all these objects. And when the array fills up, we just declare a new array of twice the length of the old array. Okay, so just at any point you have a concern, just let me know. Okay, so here's an example of how we use ArrayList. You know, we just go, this is before generics, we just declare the variable. Here's our constructor on the right. And then we add a string. Well, let's say we can add a person object too. So, you know, I create a funny name, JS, and the age is 20. Okay, so then I say, okay, let's get the object at position 0. Well, the first one we added was volcano. Okay, so we have to cast, because the thing about the get method is that it returns something of type object. So every string is an object, but not every object is a string. So it's possible at position 0, there's a person object there. So when you cast, what we're saying to the compiler is, I guarantee you that at runtime, the object at position 0 is going to be a string. So the compiler just kind of is basically, we're saying to the compiler, trust us, this will work. Okay, and if it doesn't, then your program crashes. Okay, but without that string, and I have a slide later, without that string right here, parentheses, to take that out, the program would not compile because we'd be returning object. Okay, so. And now we introduce generics. And if you open up the ArrayList class, there's actually a lot more, and this is highly simplified, but the one thing that you would see, do you see the diamond operator after ArrayList? So we have ArrayList less than E greater than. So that E actually represents a class name, and E is the generic variable. And so you see how all these E's map. So we're going to add something of type E, and we're going to return something of type E. Okay, so the thing is, if you can only add something of type E, like E might be string, or E might be person, or integer, just take your favorite class and substitute it for E. Okay, but if we can only add E objects, that means we're only going to get E objects in return. Okay. Okay, so now let's go to, we saw this in the code. This is a very common, this is your typical way of declaring an array list. Okay, so in the diamond operator on the left, we put the class name in. So it's any legitimate class name. It could even be array list. That'd be kind of silly, but any legitimate class name can go inside the diamond operator. And so wherever the compiler sees E on the previous, all the E's on the previous slide, the compiler does substitute string for it. So the compiler sees this line, ArrayList string ARR, and then goes in, when it looks at the code for the ArrayList class, we'll substitute all these E's. Wherever it sees E, the compiler just pretends it's string. So the compiler thinks, just pretends that when we declare the ArrayList with string, the compiler thinks that the add method can only take strings, and the get method will only return strings, right? Because the E is in the input parameter, and for the get, it's the output parameter. So the great thing is that now, this is why when you use generics, the compiler is checking. If we try to add something, if we try to pass a parameter to add, and it's not a string, you're definitely going to get a compiler error. Okay, so this is perfectly okay. Okay, so Volcano matches the data type. So what's inside this add, the data in the add has to match the generic variable, that in this case is string. And we don't have, here's another advantage of generics, we don't have to cast anymore. Do you see how up here, without generics, we must cast because the get returns something of type, the highest level object of all. We add a string, but we're going to get out an object. So if we want to assign it to a string variable, we want to assign the value returned by get to a string, we need to cast. But here, there's no need to cast. And why? It's all because of this. We can only add, if we add strings, the only thing we can get in return, the only thing that we can get is a string. We're restricted to adding strings, so the get can only return a string. So there's actually no need to cast if you're using generics. So the two things with generics, the most important, I think, is that the data is checked. The data is checked at compile time, and it's a real convenience that you don't have to cast. It makes for cleaner looking code. Okay, and so this is what I'm saying here. This is what the example I was talking about before, is that without generics, the get method returns something about type objects, and so object is it's the highest level class of all. String extends object. So this get method returns this type of object, but it could be returning a person or an integer, not necessarily a string. So we have to verify to the compiler, oh, the element in position 0 is really a string, because the compiler will just assume it's any kind of object. And so one last thing here, yeah. Okay, so again, and then probably the most important thing is that the compiler verifies the data type. So in this case, it says we're only going to add integers to this array list. We're only going to add integers to this array list. So, and now we're trying to add a string, Volcano. So you actually get a compiler error right here. Right? Because Volcano, this data type Volcano does not match integer. So, okay. So yeah, because now the maybe I left this from yesterday when I was working with the other students, but because now the add method, because we declared the array list with the integer as the generic variable, the add method is now public Boolean add integer x. And it's Boolean, it always, for array list, the add method always returns true. There are other collection classes like, there are other collection classes where we don't want duplicates. So we want to use the same methods for all of them. So, okay, so there's some like a collection, so we don't allow duplicates, so the add method in that case might return false. But we want the same add methods for all these collections. There's a wide variety of collection classes, and we'll talk about array list, or we'll go into one of them in detail, either array list or linked list, probably more linked list than array list. So I'm going to stop sharing the screen, and I maybe wanted to talk a little, just go over the, to say something about the assignment. I don't think I posted a review file, because there's no, yeah, no, I haven't posted any review. I'm going to post a review question for our next quiz, which will be at the end of next week. And it's kind of a short lecture. I think I had more questions. Maybe I could talk longer than I said I had more questions, but that's okay. But and also some students had questions on their program, so so I think I talked longer last time too. So this is all I want to say about generics. It will not be on your next quiz. I might not be on any quizzes at all, other than, well, yeah, I'm going to ask you to write there's something called the comparable interface, which we haven't gotten to yet. Yeah, and that involves generics. But so I'm going to post a reading assignment on the comparable interface. So I'm going to stop sharing this. I might go back to Eclipse just to talk about my. So that's all there is about generics, and we're going to use it some more next week. So the next lecture, which will be next Thursday, is going to be on. I'm going to talk about the comparable interface, and we're also going to start the sorting and the searching. We're going to talk about, and I'll post a reading assignment on binary search, and so and then I'll post some reading assignments over the week. Yeah, binary search, and also the interface material, and some material to help you prepare for the next quiz. But if there's any questions, I wanted to go back to Eclipse and talk a little bit about the assignment. And I just have to find this. And I'm going to post some hints on, hello, what happened here? That's not what's supposed to happen. Okay, so now let's see here. So let's just look, I'm just going to look at the two classes. I posted an application to help us. I posted an application as an example of how to extend the class and how to write the equals method and how to extend the two-string, override the two-string method. So I posted two files as an example, person and my person. So here is my person class. And just from talking to students, I am going to, early this evening, I want to post some hints just to make it easier for you to get the programming done. Okay. So one thing, students, is, do you see, so there's actually two students. So it's actually one thing, student. Okay. I guess I could just say Julio as well. Okay. So, okay. 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 So here's our famous person class. Maybe this is the first class that you ever wrote in Math 130. And, 3 instance variables. And then we have the typical constructor for assigning values to the instance variables. So we create an object and we pass like a first name and a last name and an age to the constructor. And so then the object gets initialized. The first name, last name, and age instance variables get initialized. But now there's actually 2 ways of creating a person. I wanted to see if my test person file does it. I have 2 constructors here, which means there's actually 2 ways to create a person object. So maybe I'll see, I can't remember if I did this in the test file. So person P, new person. See, I can actually, create a person object, and then the parameter list is empty. So it's going to call this, why is this? Oh, because it's didn't put comment here. Okay, so what's going to happen is if I use this second constructor, what do we see here? We see the keyword this. We know it's a keyword. It's highlighted in that kind of purple. and then I have a string, it's this, and then it's string, string, integer. And that's what this first constructor is. Look at its signature, string, string, integer. So what I'm doing is that we're passing, okay, so on line 21, actually, and see it here in the comments, this is what I say, invokes the first constructor. So what it does, it just passes, like I'll just do one of them, it just passes first name to, is going to be Pilar. Okay, and then the last name would be, oh, where am I here? The last name would be S, and the age would be 54. So when we call this constructor with no parameters, we're creating a person object where the first name is always Pilar, the second name is always S, and the age is always 54. So in the My Student class, and I'm going to post some notes tonight, the My Student class has two constructors. And I can't remember what I'd have to go look and see what I have in the second constructor. But just remember, the second constructor is supposed to call the first constructor. I think it kind of hard codes the major. Yeah, I think it says I think it's, yeah, I don't know if it actually is a major, it just hard codes the major. But that second constructor in My Student should be one line. See, notice I'm not, so this would be bad. See, sometimes I tell students to, make the first name Pilar and the first name Pilar and the last name S. So this is what I see some students doing. This, whoops, my typing is terrible. This dot first name is assigned Pilar. So this is not what I want you to do, because now it's going to actually take 3 lines to make these assignments, right? And I say just use 1 line. And mostly what I'm trying to do is just to get you to use the this keyword to call a constructor. See how we had to use, if I don't use this, if I don't use this left, see if I go this left paren, I'm calling a constructor in the same class. If you go this dot, you're referring to an instance variable or a method in the class. If you go this left paren, you're referring to another constructor. And you just look for the constructor whose signature matches. So this string, string, integer. And luckily we have one of those. Otherwise we get a compiler error. So make sure in that second My Student constructor that it only has 1 executable line of code. And it should start with this left paren. Okay. And I'm happy, and if anyone has any questions, just email me your files. And there's just unless there's any questions, I just have one other thing to say. I wanted to look in the My Person class, the class that extends person. But also students, just want to remind anyone who's looking at this video, or Julio, anyone's looking at this video, I do have an example of an equals method in here. So just look at that. Let's just look at My Person. So this is also posted as part of the assignment this is an example. So this one only has 1 constructor. But notice the first thing, students. See, the first thing that if every constructor either has to call, it'll either start with super, left paren, or go back to person, or this. Oh, so I'm going to take this. This should all be comments. Or it starts with this. Now notice that, see how this constructor here, person, the first line doesn't start with this left paren, it doesn't start with super left paren. So if you don't explicitly call a constructor in the same class or call a constructor in the parent class, what it does, it puts this line of code in. So if your constructors don't start with super left paren or this left paren, it actually has that line of code that I just typed in line 14. It's invisible most of the time. And what it's doing, what it does is it calls a constructor in the parent class that takes no parameters. Now, most of the time, if our classes aren't extending another class, that means they're extending the object class, and the object class has a constructor with no parameters. So we're all set. But if you don't explicitly, if you're extending a class like we are here, say we're explicitly extending a class, My Person extends person, one of your constructors really should start with super left paren. Otherwise, without this, see if I don't go like this, and see if I don't go like this, what I really have is now I have this. Now in this example, it's okay because the person class has a constructor with no parameters. But that's not what I want to do. So what I want to do is when we create the see, when we create a my person object, see, the thing about my person has one extra field, height, or instance field. Instance variable height. Okay, so what we want to do is that we want the parent class, the one that defines first name, last name, and age instance variables to initialize first name, last name, and age. So that's what that super does. And then the constructor in the child class has to initialize the instance variables defined in that class. So just make sure we have, because I've talked to students who are like my student are not calling super and they're not calling this in their constructors, and so they're running into problems. So this is, and if this looked odd or strange or like what when did we learn this? It should have been at the end of Math 130, and I can understand if you forgot because. Or maybe I don't know if the teacher went kind of fast. I know it gets to the end of the year and oh my God, I'm running out of time to do all this material. And you don't really get to see a lot of examples. This is kind of sophisticated stuff. And you don't really, it's probably not an adequate amount of time in Math 130. And then you're off for the summer. And then plus, we weren't meeting, face to face at the end of last semester. So I'm going to post some hints about this. I'm just going to post this, a file this room. There's another hint I want to talk about too. So, so that's pretty much it for me for right now. And I'll post this recording, but Julio, do you have any questions for me right now?
No, I actually don't. Everything was pretty straightforward.
So if you have any questions on your assignment, just email your files to me, okay?
All right, sounds good.
Okay, then I'll post the hints about the assignment sometime after dinner.
All right.
Okay. Well, I'll stay here until you you have no more questions. I always stay here until I'm the only one in the Zoom room.
All right. Yeah. All right. See you next time.
Okay. Yeah. Have a great weekend.
You too.